everybody, I am David Tepper. I was with Microsoft for 19 years. I've been in the Gen AI space since 2009. My first patent in Gen AI was in 2011, if you can believe it. And I represented Microsoft in speaking about Gen AI to the US Congress and the United Nations. I ran internal Gen AI consumption for strategy, Gen AI strategy for Azure. And I only have 10 minutes to show you how to measure the business value of your agent. So buckle up, because this is going to be a little mathy. So first of all, what is an agent? It's something that controls the clicker. There we go. All right, I have to point it this way. These days, raise your hand if you're an agent. Like, everything is an agent. This microphone is an agent. Like, agents are deployed all over the place. But if we're going to understand like how to talk about measuring the business value, we're going to have to come to a common understanding about what an agent actually is. So first of all, when people refer to an agent, they usually refer to one of these three things. And of course, if you have other categories in mind, they'll probably map to one of these. The first is a workflow. So this is like traditional code that uses an LLM as a part of its normal execution. So I've got a bunch of like standard stuff, and I just threw an LLM in there. We'll call that a workflow. Second is a pipeline. Most chatbots are pipelines. That's when I've got like a series of LLM calls or RAG calls and things that are always running in exactly the same set of steps. Number two is far and away the most common, particularly for enterprise use cases. And number three is something that is actually agentic, where I've got a variety of tools. It's making decisions at runtime. It's deciding where it wants to go off and execute things. Now, for this conversation, we're actually going to treat all three of these as an agent. And we're going to talk about how to measure the business value of these things. But that means that we have to also come to a shared understanding of what business value actually is. Now, business value may feel different to each of you based on your type of business that you're in. So for example, if you're taking care of the elderly, like the value might be like the warm and fuzzy feelings that you get, when you're helping people out. But in order for us to talk about measurement, we have to talk about quantification. And so that means that we're going to find ways to, this clicker is low on battery. There we go. We're going to find ways to actually quantify business value. And the first of these is simply financial value. That's either dollars that are saved or new revenue that's being generated. Time savings, which of course, minutes, you can pick your favorite time unit. And then productivity. Productivity is usually in 2 units, so like X number of times per day. I used to do this thing. We'll use tickets, so I can process X number of tickets per day. We'll just call that as our simple productivity measure. And for each of these, we'll talk through how to do the calculation. So this is the world's most basic ROI equation. We talked earlier about how net profit, can either be from savings or from net new revenue. But the other part of this equation is the cost. And understanding the cost of an agent is something that is a little bit tricky. In fact, it's phenomenally complex. So let's look at some examples. Normally, if you look at two products and if you think they have the exact same price and you do the exact same things with them, then the costs must be identical. But that is absolutely not true for large language models. Not every charging methodology is based on tokens, but the ones that do use different tokenizers. And that means that the exact same sentence across two different models can have very different costs. I see you nodding over here. For example, the new version of Opus that just came out is exactly the same price as the prior one, but it uses 30% more tokens. And so, of course, it's 30% more expensive. So if you want to switch to a new model, how do you know whether that's going to be more or less expensive? Also, you are charged for things apart from text. For example, sending images into the models. Who has ever seen something like this? Vision pricing is not typically listed in the pricing matrix. So this is how you calculate what are called tile tokens for OpenAI. It has to do with the size of the image that you're sending into the model. It gets incredibly complicated. What's also cool is that context does not grow linearly. So in this example here, every single time you send a message, you're sending the entire context history of that chat over and over again, which means that if you send an image in the first message of your chat with an agent, that image is getting resent for every single subsequent image, and you are getting recharged for that hidden fee. Bet you didn't know that was happening. It turns out that pricing is immensely complicated in general. These are all the prices for GPT-4o. It's a particularly old model now, but you'll notice that I even have different prices for the same model when accessed from different SDKs. And if I'm provisioning capacity, which is the stuff you see in the reserved instances here, it's so complicated that OpenAI says on their website that they're going to release a tracking system for this in Q2 of 2023. They're a little late. That is still up on the site, by the way. That's what all those 3D models in the middle are there for. And so obviously it's super involved. I'm not even touching this thing anymore. It's actually just moving through the slides on its own. You're doing it for me? Okay, because this thing's battery's dead. Thank you. So also, the cost of a request is not the cost of an agent. So even if you know the cost of that like single AI call that you just made, regardless of all the different things that you're getting hit with, you've got a whole bunch of those that are happening as a part of the agent, and it's changing all the time as it's leveraging a variety of different tools and services. Also, by the way, agents have an average of 3.5 models. That's the industry average for the number of LLMs that they're using. Now, number two, we talked about time savings. Now, in order to understand how much time you're saving for your agent, you have to get get into Gen AI latency. Gen AI latency latency is interesting because we're all familiar with end-to-end latency, but you have all those other latency characteristics that are really important. Those are the ways your customers actually experience the snappiness of an agent. And I don't have time to get into all of those in a lightning talk, but let's go back. There we go. And number 3 is productivity. So let's imagine I've got an agent where, as a human, I can process 100 tickets a day. But with my agent, I can process 1,000 tickets a day. However, some number of those tickets are wrong, and I have to either redo them and I have to review and understand what's going on. So how does that impact productivity? And so step 1 to solve this problem is to split the problem into use cases. It doesn't matter whether it's a workflow, a pipeline, something that's truly agentic. What matters is the actual use case that's being tackled, not the technology. These are some example use cases. These are the most common ones we see in our hundreds of conversations with enterprises. You'll notice that I'm not listing something like co-pilots or agents here. Those are not use cases. Those are technologies that enable you to actually perform additional use cases over the top of them. For each of these types of use cases, you have tangible outcomes. You have measurable objectives, and that's really what's core. So step 2 is tracking quantifiable KPIs for each of those use cases. So once you get to those outcomes, you have to measure their efficacy. ROI is not a KPI. ROI is what you get after you've assessed whether or not you've hit your intended objectives. Again, with the nod. This person knows a lot about AI. All right, let's move on to the next one. Thank you so much. So let's talk about KPIs for use cases. Here are 3 sample use cases that are particularly common, and we can see some example KPIs for those. Now, each of these has to be quantifiable in some way. And what we've discovered is that as you look across a variety of different use cases in the industry and you're trying to measure all of these with KPIs, it turns out that those types of KPIs will always fall into 4 buckets. And again, we're talking only about quantifiable ones here. The first of these is Booleans, true or false, and those can lie into a percentage. So for example, whether a customer was satisfied or not, thumbs up, thumbs down, and at what percentage of, say, chats, for example, they were satisfied. The second is numbers, just any old numbers. Of course, that's a quantification. And then you've got Likert, that's like a 1 to 5 star, 1 to 10 star, and so on, right? So between Booleans, numbers, percentages, and Likerts, you have captured pretty much everything that you need in terms of quantifying the success of these KPIs. So step 3 is now that we have the use cases, now we have a KPI and a way to quantify how successful it is, we have to determine what business value actually is. And so for that, let's look at those 3 equations. So for number 1, for financial value here, we talked about how net profit can come from a variety of things, like hashtag AI is taking all of our jobs. Oops. Back one. There we go. Thank you. But now you can calculate it as a result of your KPIs. And so this is that personalized marketing example from earlier. These quantifiable KPIs along with your business logic can give you the numerator. What was your profit from running all of these ads? And then once you've understood the cost, then all of a sudden you can calculate the ROI. Let's move on to number 2. There you go. Now, to understand time savings, we'll look at a new equation here. In this equation, S is simply an indicator of whether or not the task was completed to satisfaction. If it was, then you're saving on the normal amount of time it would have taken for a human to do this. So, multiply N, N becomes 1, or S becomes 1, and so you get N. But then it also takes the agent some time to actually perform this activity as well. And so this one equation will actually capture all 3 states. The state where an agent failed at its objective, and then all of a sudden I'm just losing a bunch of time because I'm spending time on the agent itself. An agent that succeeded at its objective, and now I'm saving a bunch of time as a result. Or the more nefarious one where an agent maybe succeeded at its objective, but it didn't save me as much time as I would have hoped. Right? And that actually becomes very, very plausible as you start to build larger and larger agentic systems that require a lot of time for a human to review. Let's move on to the next one. Productivity. All right, so this one is a bit more complicated, and I'm not going to walk through the entire algorithm, but I am going to leave you with just sort of a verbal snapshot, right? Just something to keep in your head that you'll remember and you can take away with this as you go on. An agent is improving productivity if the probability of it achieving its objective is greater than the time it takes for a human to verify the result divided by the time it takes for a human to do it themselves. I'll say that one more time. An agent is improving productivity if the probability of it achieving its objective is greater than the time it takes for a human to verify the result divided by the time it takes for a human to do it themselves. So for example, if I've got a use case that's very, very hard for a human to do, but very easy for a human to verify if it was done correctly, then my agent doesn't have to be that high of a probability of success for it to add to my productivity load. Conversely, if it takes me the same amount of time to verify it as it does to do it, then my agent basically can't add to my productivity. Now, all of this is only true in the cases where the amount of time it takes me to redo the thing is equivalent to the amount of time it would have taken me to do it in the first place. So for example, if I have a customer support chatbot and they start telling the customer, hey, of course you can return that, or here, yeah, this is a free vacation that you just won by chatting with me, that's going to take a lot more time to unwind. And so that starts to have negative productivity impact. So this was a very, very quick look. I'm exactly on time here, and I can't move to the next slide. Oh, there we go. All right. Thank you all.
Hey everyone, producer Andrew here. Thanks for watching. Check out the rest of our channel for more FinOps content. Like, subscribe, and leave questions and comments for our speakers. We appreciate your support.